We have sent humans to the moon and robots to Mars, but did you know we have barely scratched the surface of our own home? Even though we live on the Earth, the center is actually one of the most mysterious places in the solar system. You might think we could just dig a hole to see what is down there, but the first big question we have to answer is why can't we just drill to the center? The answer is that we have tried, and it is much harder than it sounds. The deepest hole humans have ever drilled is called the Kola Superdeep borehole in Russia. It took 22 years to drill down about 7.5 miles, which sounds like a lot, but that is only 0.19% of the way to the center. At that depth, the heat was so intense that the rocks started acting more like plastic than stone, and the hole kept collapsing because the rock was so squishy. If we tried to go all the way, the temperatures would reach nearly 10,000 degrees Fahrenheit, which is about as hot as the surface of the sun. This heat would melt any drill bit made of any material we currently know how to build. Plus, the pressure down there is 360,000 times stronger than what you feel at sea level, which would crush any equipment instantly. So if we can't dig there, how do we actually know what the core looks like? The secret lies in using earthquakes as a giant planet-sized ultrasound. Whenever an earthquake happens, it sends shock waves through the entire planet. Scientists use machines called seismographs to listen to these waves as they travel through the earth and come out on the other side. This leads to our next big question: how do these waves actually show us the layers if we can't see them? Well, there are two main types of waves we look at, called P waves and S waves. P waves are fast and can travel through almost anything, whether it is solid rock or liquid metal. But S waves are very picky and can only travel through solid material. Seismologists notice a massive mystery. When an earthquake happens, the S waves completely disappear when they reach a certain depth. This created a shadow zone on the opposite side of the planet where the waves just couldn't reach. This told scientists that there must be a giant layer of liquid blocking the S waves, which is how we discovered that the outer core is actually a sea of molten metal. But then, does that mean the entire center of the Earth is just a liquid puddle? For a long time, that is exactly what people thought. But in 1936, a brilliant scientist named Inge Lehmann noticed something strange in her data. She was a pioneer who used to organize her earthquake reports in old mailboxes because computers didn't exist yet. She saw that some P waves were bouncing off something in the very center and showing up in places they should not have been. She realized there had to be a solid ball of metal right in the middle of all that liquid. This is the solid inner core, a ball of iron and nickel about the size of the moon. Even though it is hot enough to melt, the pressure at the very center is so high that the metal is forced to stay solid. But wait, how do we know for sure it is made of iron and nickel if we have never seen a piece of it? This is where things get really cool, because some of our best evidence actually comes from outer space. Our next question is what do space rocks have to do with the Earth's core? Scientists study meteorites, which are like the leftover building blocks from when the solar system was first made. Some meteorites are made of almost pure iron and nickel. We believe these are the actual cores of baby planets that were smashed apart billions of years ago in giant space collisions. Since Earth was made from the same ingredients as those other planets, it makes sense that our core would be made of those same heavy metals that sank to the center where the planet was still molten. Finally, you might ask, is there any other way to prove that all this moving metal is actually down there? The answer is all around you right now, in the form of Earth's magnetic field. The liquid outer core is constantly swirling, and because it is made of metal that conducts electricity, it acts like a giant generator called a geodynamo. This movement creates the magnetic field that protects our planet from space radiation and makes your compass work. Without a liquid metal core, we wouldn't have a magnetic field, and Earth would have lost its atmosphere a long time ago, looking more like the dry, dead surface of Mars. It is pretty amazing that even though we have never been there, we can use math, earthquakes, and space rocks to map out the heart of our planet. So the next time you use a compass or look at a map, just remember you are feeling the effects of a giant metal engine spinning thousands of miles beneath your feet.